So far, we have covered the legal foundation, liability directives and standards, and the engineering core, safeguards, control, safety control technology, and safe communication. Part 3 complete the picture with chapter 7, 8, 9. Safe motion meaning safety function integrated directly into the modern drives, mechanical, pneumatic, hydraulic design, because safety is not only electrical, and the and then which turns the book into a working reference. These chapters share one theme: protecting people with sacrificing productivity. Let's start. Why does safe motion deserves its own chapter? Because in modern machines, almost every hazard movement comes from an electrical drive. And the old philosophy, cut all powers and wait for standstill. This is increasingly unacceptable. It destroys the productivity, it can even reduce the safety, because long restart procedures tempt operators to bypass the safeguards. Safe motion means the drive itself become part of the safety system. It can move torque, bring an axis to a controlled stop, hold a position under active monitoring, or supervise a reduced speed while an operator works nearby. A safe shutdown become a last resort, not a default reaction. The governing standard is EN 61800, which covers the adjustable speed electrical power drive system with safety function, abbreviated PDS-SR. Its great contribution is a catalog of precisely defined standardized safety function with common names and common behavior, so that a machine builder, a drive vendor, and an assessor all speaks the same language. A drive integrated safety function is engineered and assessed like an other safety function. It sits inside a safety loop, and its contribution is qualified with same measures we saw in part 2. A performance level under ISO 13849, or SIL under EC 62000 or 61. The compendium walks through the definitions, the system examination, and worked examples. Let's look at the stop function first. STO, save torque off. Immediately remove the torque generating energy from the motor. The axis goes down, but it can never start unexpectedly. SS1, safe stop 1, first declares the motor in a controlled way and then activate STO. Once it's reachable, it should be standstill. SS2, safe stop 2, also breaks in controlled way. But instead of removing torque, it transitions into SOS, the safe operating stop, where the drive actively holds the position under the closed loop control and monitors it against any dangerous movement. Choosing between these functions depends on the load, on the vertical axis, and on what process can be tolerated. Beyond stopping, the standard also defines monitoring functions that enables interaction while the machine keeps running. SLS safely limited speed supervises the motor against a defined speed threshold, and that is what allows setup work with the guard open at reduced speed. SDI safe direction ensures the axis can only moves from the operator, never towards them. S SLT safely limited speed limits torque and force. SBC provides safe brake control for holding brakes, critical on vertical gravity loaded axis, and SSM gives safe feedback signal whenever speed is below a limit. Combined these are basically combined intelligence, and these functions turns stop everything into move safely, which is exactly the productivity argument the compendium keeps emphasizing. Chapter 8 starts with a reminder. Before any sensor or safety PLC, safety is mechanical discipline. Inherently, safe design is the first step of the ISO 12100 method, and this chapter shows how it means practical. Avoiding cush or shear points through geometry and minimize gap, respecting safe clearance, selecting materials and dimensioning components with adequate safety factors, ensuring stable against stripping, and designing for safe operation and maintaining access. A hazard that designs out never needs to be guarded, monitored, or validated, and that makes good mechanical design the cheapest and the most reliable risk reduction available to us. Pneumatic systems have their own failure modes: stored energy in the compressed air, unexpected motion at startup, and gravity driven movements when pressure is vented. The reference standard is ISO 40414 for pneumatic fluid. The compendium discusses safe venting and exhaust concepts, protecting us against unexpected pressure buildup and holding load safety. On the control side, safety functions are realized at well-tied components and redundant valve arguments. For example, dual channel safety valve. And these pneumatic parts enter exactly the same performance level calculation as electrical components under ISO 13849. Fluid power is not exempt from the function from the functional safety. It is a full participant. Hydraulic raises the straits with a very high pressure and heavy suspended loads. ISO 40413 is the reference standard for hydraulic fluid power, and the compendium dedicates a section to the safety requirements on the hydraulic circuits. The recurring themes: bringing movement to a safe stop and holding it there. For example, with monitored leak tight holding valve on the vertical axis, manage accumulators which stores dangerous energy even after the pump has stopped. Controlled pressure released before maintenance. a protection against hose failure. Once once again, the design pattern is familiar. Redundancy, monitoring, well-tried safety principles, just expressed with hydraulic components instead of the contactors or relays. And that brings the series to a close. Across three parts, we have traveled the full arc of Pilz Safety Compendium, from product liability and the machinery directives to risk assessment, safeguards, performance level, and safe networks to drive integrated safety functions and fluid power design. If there is one message to take away, it is this: machinery safety is a system discipline. Legal, electrical, mechanical, organizational at the same time. And the standards are not bureaucracy, they are engineered experience. Thank you for following this series. The full compendium is free to download from the Pills website. I will love to hear from your feedback for anything else. Thank you.